Okay, this is the P2 paper from January 2021. It's question number 2, and as we can clearly see, this is a differentiation question, but then leading on to stationary points. It's fairly straightforward, so let's make a start to it. Part A says, using calculus, can you find the x coordinates of the stationary points of the curve? Well, straight away, you should have in your mind stationary points are when dy by dx equals 0. So let's go ahead and do that. We've got that y is equal to x cubed minus x squared minus 16x plus 2. dy by dx then is the differential of that. So multiply by the power, take 1 off the power, multiply by the power, take 1 off the power, and the 16x becomes just 16. The 2 disappears, obviously. So as I just said, at stationary points, let's tell the examiner what I'm doing. At stationary points, dy by dx is equal to 0. So I'm going to get that this quadratic is equal to 0. That's no problem at all. So I'm going to get 3x squared minus 2x minus 16 is equal to 0. So now we're looking at solving quadratics. I'd always try and attempt to factorise it first of all, then use the quadratic formula afterwards if it doesn't. And elsewhere on my channel is how to do videos which show you how to get to this stage. So I'm not going to do it here. Factorising that out comes to 3x minus 8x plus 2. So we get 3x minus 8 equals 0, which is going to give me x equals 8 over 3, or x plus 2 equals 0, which is going to give me x equals minus 2. On slightly more complicated questions, you'd go back and just make sure that you can have positive and negative values, given the criteria of the question, but here it's just straightforward. 4 marks. Yep, easy, let's get those ones. Then part B is just also testing, are we aware how to determine the nature of stationary points, how to tell between maximums and minimums, and we can look at the second differential. So if we look at the second differential, if the second differential is positive, it's the opposite of what you'd expect. A positive second differential means a minimum, and a negative second differential will mean a maximum. Let's go ahead and do it, and you'll see me actually do that. So second differential, d2y by dx2, dy by dx is up there, so the differential of that, same rule, multiply by the power, take 1 off the power, etc. So I'm going to get 6x minus 2 as my second differential. So when I'm saying about whether it's a positive or a negative, I need to use the values that I've got. So if we start with x equals minus 2, so x equals minus 2, is this going to be a positive or a negative? Is it going to be a maximum or a minimum? d2y by dx2. Oh my goodness, my handwriting there is absolutely dreadful. Let's try that again. By dx2 is equal to 6 lots of minus 2, which clearly is negative. It's minus 14. This is negative. Doesn't matter the fact it's 14, it's the minus that counts. It's negative. Therefore, it's a maximum. The point is a maximum. Excuse me. And we'll do the other way around. Now, clearly, if you've got one maximum, you're going to have one minimum for a cubic, but let's go ahead and just do it anyway. So x equals 8 over 3. The second differential would be 6 lots of 8 over 3 minus 2. Let's work out what that works out to be. Oh, works out to be 14. Okay, but it's positive is all that I'm interested in. If it's positive, then, therefore, the point, handwriting absolutely all over the place, the point is a minimum. Let's just go back and check there's nothing else. Yeah, it just says the x coordinates there. It doesn't say the entire point. And then it just says whether they're maximums or minimums. So really straightforward there. They could have made that much more complicated, but they're just testing some really basic techniques there. Hopefully that all makes sense.